Hi there everyone, my name is Zafan, and today we're going to continue talking about antiderivatives. So if you watched my previous video, I basically started the introduction into integrals and how we do integrals, what the purpose is. Well, I didn't go too much into the purpose, but I'm just starting to introduce the topic of antiderivatives. So in this video, I just want to continue. So a quick refresher on the last video. We learned how to take the derivative not the derivative, see I'm messing up. We learned how to take the integral of x to the n. So I'll just refresh what I mean. So if I had the integral of x to the n dx, this dx is important, the integral would just simply be, or the answer to this would be x n plus 1, and then n plus 1, and then plus c. So that's one property we learned. So if we just had x to the 5, then it would be x to the 5 plus 1 divided by 5 plus 1. We learned that last video. So today I'm going to introduce another one, and I'm also going to introduce a few properties. So just things that will help us take integrals. So the other integral I wanted to introduce was, let's say we had the integral of a number. So let's say it was 1, okay? So what's the integral of 1? So again, remember it's the opposite of differentiation, right? So if I took the derivative of, let's say, the derivative of just x, I would get 1, right? So if I take the integral of 1, well, I just get x plus c. So if this is the integral I was taking, I get x plus c. Again, antiderivatives, it's literally in the name. You're doing the other process, or the opposite process of differentiation. So if I were to differentiate this, right, I'd just get 1, right? dy dx of x is just 1. So the integral of 1 is x. Now that we have that down, let's do a couple properties of integrals. Alright, I'll show you. Actually, you know what? I changed my mind. I'm going to do a few more just a few more integrals to show you. So what are the ones we know right now? We know that if it is x to the power, so a polynomial function, we can integrate it, right? Just raise the power by 1 and then divide by the power plus 1. And if we have a constant, the integral of a constant, it's just x, or 2x, 3x, whatever the constant is. If it's 3, it's 3x. If it's 5, it's 5x. Simple? So let's take the integral of a few more things, okay? So let's say you had the integral of cosine x dx, right? What would the answer to that be? Well, you know that if I differentiate sine of x, I get cosine of x. So if I integrate cosine of x, I get sine of x, correct? So sine of x plus c. You good with that? Hopefully we are. So that's 1. So let me erase that, and let's do another one. So yeah, you can probably expect it already. Now I'm going to do sine of x, alright? So what's the integral of sine of x? Well, if you remember, when I take the derivative of cosine x, I get negative sine x. And when I take the derivative of just, wait, let me rephrase that. When we take the derivative of cosine x, we get negative sine x. So if we're taking the integral of positive sine x, we will get negative cosine x plus c. Alright? Hopefully you're able to follow this. All I'm doing, again, is just doing the opposite of differentiation. I haven't done anything new. All I'm saying is that instead of going from derivative, like instead of taking the derivative of a function, we're taking the antiderivative. We're going backwards. Alright, so now hopefully we have 4, I believe, right? We have our constant, we have x to the power, and we have sine of x, cosine of x, right? We know the derivatives of that. Now I want to talk about a few properties. So what if we had a constant multiplied by f of x, right? So what if it looked like 2x, alright? What if the integral looked like, sorry, let me add the dx, that's important. What if I had something like that? What if there was a constant being multiplied by x? Well, there is a trick to doing this. Guess what? I can just, let me erase this, I can just bring the constant out, alright? And then differentiate my function, or integrate my function just as I would. So I can just bring the constant out, and I would have f of x dx. So let's do an example of that, alright? What do I mean by this property, alright? Hopefully I'm not going too fast. If I am, please leave a comment down below to tell me to go a little bit slower if that's what you want. I can go do that anytime. So let's have the integral of 2x dx, right? So let me just flip the page, so I have this in front of me. So 2x dx, right? What would the integral be? Well, I have a constant being multiplied, right? And this is a constant. It doesn't have anything like any special meaning. So what I can do is I can bring the 2 out, and then I just have x dx. Does this look like something I can integrate? Yep, it's just x, right? So I increase the power by 1, and I divide by the power by 1. So it'll be 2 multiplied by, because I am multiplying, and let me bracket that, so x, 1 plus 1 is 2, divided by 2, plus c, right? Now I can bring it in, so these would cancel, and I would just have x squared plus c. So this, remember, if you saw this and you're like, what's the opposite of that? It would just be x squared. Yeah, that's all there is to it. So what did I do? A simple integral property is I can take the 2 and I can just pull it out. Let's just pull it out for the moment, okay? Let's do another example of this. Another example of this property where we can just pull out a constant, alright? Let's say we had the integral of 4 sine of x. Okay, dx, right? So what would the what would the derivative of the integral of that be? Sorry, I keep messing up derivative and integral, and that's happening to me a lot because I'm doing both sides of calculus at the same time, really. So confuse those two. So again, I can't do 4 sine of x, but what I can do is I can bring the 4 out. So I'll bring the 4 out, and I'll just take the derivative of sine x dx. Alright, so what is the integral of sine x? Well, we just covered that previously in this video. We know the integral of sine x is simply negative cosine x. And plus c, so I can just say the answer to this is negative 4 cosine x plus c. Hopefully you followed that, right? I couldn't do 4 sine x, I just brought the 4 out, and then I integrated sine of x just as I usually would. So equal sine. And again, remember that plus c, right? Because whenever we differentiate, constants disappear. So if we're anti-differentiating, we bring back the constants. Simple as that. Alright, now that we know that, I'll show you one more property of integrals for this video. Right? So another property is, what if we had the integral of a function plus another function? So what if it was like x squared plus x cubed, right? What would the integral of that be? Well, I'm here to tell you that you can just separate the two functions. You can take the integral of this, and then you can take the integral of that, and then add them together. So what does that look like? That is equal to the integral of f of x dx plus the integral of g of x dx. If you're wondering what the dx represents, it's just we're saying we're taking the integral with respect to x, just like dy dx. You're differentiating with respect to x. So again, back to the topic at hand. If I have the integral of a function plus a function, it is just equal to the integral of that one function plus the integral of that function. You can always break it up like that. So let's do an example of this. Okay, so let's see if I have an example handy dandy with me. Should I? I should have one. Yes, I do. So let's say I had the integral of x squared plus x. That does not look like an x, that's a 3. Okay, plus x to the power of 3. How would I integrate that? Well, if you remember our property, I can basically integrate this, and then I would integrate, so dx, my bad, and then I would integrate x to the power of 3 dx. So let's go ahead and do that. What's the integral of x squared? Well, I add 1 to the power, so 2 plus 1 is 3, divide by 3, plus c, or I'll leave the plus c for now. You'll know why. And now let's take the integral of x to the power of 3. So what's the integral of x to the power of 3? So you add 1 to the power, so 4, and then divide by that, right? And let's just add 1 constant in general. I could add a constant here and then I could add a constant there, but a constant is a constant, right? You add a constant by another constant, you just get another constant. So just one big constant is okay at the end. So we had the integral of x squared plus x cubed. I took the integral of x squared first and then x cubed, and then I simply just added the two. Hopefully this was pretty easy to follow.